Okay, fine. So let me solve the problem first. This is the problem that you need to solve. Sn plus 2 hydrogen plus gives rise to Sn2 plus H2. Right? This is the reaction you need to solve. Now the thing is that whether this reaction will take place at all depends upon what? It will happen or not. How will you say this happens or not? If E of this reaction occurring in their respective states is greater than 0, then this reaction takes place. E equal to 0, no net reaction. E less than 0, the reverse is true. That is, Sn is being reduced, hydrogen is being oxidized. Clear? So whether this reaction will take place or not depends on the electrode potential of this reaction. Now let's find the electrode potential of this reaction. To write this, so the first equation that you should write is E0 minus RT by NF ln Sn2 plus concentration pH2 concentration of Sn and hydrogen concentration. This is your reaction. So what are the unknowns here? Let's look at the unknowns. The only unknowns, nothing is unknown actually. Sn is given. Is this also given? Sn will be taken as 1. Nothing is being said about it. And pH2 is given 1. Right? This is 10 to the power minus 2. And this is pH has been given as 5. Right? pH is given as 5. So what I don't know is E0. But E0 has been given in a different way. How is given? E0, what is E0? E reduction minus left, or I write right minus left. Right minus left. Or redox potential of reduction reaction and redox potential of oxidation reaction. Now let's see what are they. Right? So the redox potential for this one, right? Sn2 plus, or for all this reaction for a combination of hydrogen and Sn. Okay. So I don't know about this product. I need to find out what is the redox potential. So redox potential for Sn. So Sn2 plus is normally written as Sn. This reduction potential. So now let's understand one thing. Sn is going to be oxidized in the forward reaction. That's what my cell is set to do, right? So this should be my oxidation reaction, right? And this should be my reduction reaction. Ideally, if all the concentration would have been 1, then the equation would have been true. I don't know about it, but this equation would have been true. So the reduction reaction here, the reduction reaction would have been this. For hydrogen reduction, we know from SIT it is 0 because everything is measured in terms of hydrogen, minus this value Sn to Sn2 plus, or let's say Sn2 plus to Sn. This redox potential is given minus 0.136, right? So it becomes 0.136. I hope I guess it's visible, right? 0.136. This is very important. So why this is right? Right is the reduction potential, which is 0 for hydrogen, and the left hand side I have my oxidation potential for SN. The reduction potential for this SN2 to SN plus would have been this one. Okay, minus 1.36. So if 0.136 would have been the ideal thing, so this reaction would have moved forward, no issue. But that doesn't happen because of this concentration things. I've already calculated, that's what I'm telling. So now let's calculate. Okay, let's calculate. So what I have known is from this reaction is E0 is 0.136 minus, if we substitute this of 3.4 into multiplied by, I guess it is, the reaction is taking place at 298 K, divided by how many electrons? 2 electrons. 2 electrons, 96,500. I will substitute into terms of logarithm 302, so it becomes natural logarithm of SN2 plus, which is nothing but 10 to the power minus 2, and minus 2 of logarithm of hydrogen plus ion. So minus logarithm of H plus, this is equal to pH is equal to 5. So if I substitute that, it will become minus 2 plus 8 plus 10. So effectively it becomes multiplied by 8. So if you substitute everything, you will get minus 0.100. How much I got? 4, I guess. So E is less than 0. E is less than 0. That means E is less than 0 means, you know, this forward reaction is not favored. The reverse reaction is true. So my option, the C option, is correct. SN2 is getting reduced to SN. This is not occurring. Instead, this reaction that is happening is this reduction is being. SN2 is reducing, is getting reduced to SN, and this hydrogen is getting oxidized. That's why the E is less than 0. Negative. The reverse is true. Okay, so that's how you calculate all the concepts. You have to understand the E0 first, then you have to understand the activity of the species will influence the standard electrochemical potential of the cell. So if all the concepts are clubbing up in this problem, so this is a very conceptual problem from that point. Fine, I hope you understand this. Okay.